Okay, Vijay, now in our NCERT textbook, the exercise 2.4, it's an optional exercise. Okay, in the question number 1, there are the two questions given to us, and simply the cubical polynomial, and for this cubic polynomial, we have the three different values that we have to check they are the zeros of this polynomial or not, and also verify the relationship between the coefficient and zeros of this polynomial. In both the question we have to calculate the same thing, right? Now let's do the calculation one by one. Suppose for the first polynomial, I will give the name of this polynomial p of x, that is equal to 2x cube plus x square minus 5x plus 2. First I will check 1 by 2 is the 0 of this polynomial or not. So simply we have to replace the value of x 1 by 2 here. So 1 by 2 the whole cube plus 1 by 2 the square minus 5 and 1 by 2 and plus 2. Now do the simplification. 2, 1 the cube is 1, 2 the cube is 8. So 1 by 8. 1 by 2 the whole cube is 1 by 8. Plus 1 the square is 1, 2 the square that is the 4, minus 5 ones are 5, 5 1 2 and plus 2. Okay, and here it's a 2 4s are 8. So we have the 1 by 4 plus 1 by 4 minus 5 by 2 and plus 2. Okay, so what happened? To make the addition subtraction, first we have to take the LCM. So for the 4 and 2, the LCM is what? 4. Here already 4 is there, so numerator 1. Here already 4, so numerator 1. Here 2 2s are 4. To make it 4, we have to multiply it by 2. So numerator 5 2s are 10. Here denominator is nothing, so 1. So we have to multiply it by 4 to get our LCM. So we will multiply the numerator also by 4. So 4 2s are 8. Okay. So 1 plus 1 2, 2 plus 8 10, minus 10. So numerator 0, denominator 4. So overall answer 0. Okay. So 1 by 2 is the 0 of this polynomial. Now let's take the another value 1. So my polynomial p of x, that is equal to 2x cube plus x square minus 5x plus 2. Now we will replace the value of x here 1. So 1, 2, 1 the cube plus 1 the square minus 5 into 1 plus 2. So now 1 the cube is 1, so 2 remains as it is. 1 the square is 1, minus 5 ones are 5 and plus 2. So 2 plus 2, 4 plus 1, 5 minus 5. So 5 minus 5 becomes 0. So p of 1 also 0. Okay. And at last, we have to check for the minus 2 also. Check. Third calculation. The polynomial p of x is equal to, it's a 2x cube plus x square minus 5x plus 2. What the value of x here I replace? Minus 2. So that is the 2 into minus 2 the cube, minus 2 in the square, 5, then minus 2 and plus 2. Okay, see negative number is there. So take care about the exponent power. Negative number odd power, answer is negative. 2 the cube, that is the 8. Now negative number the even power, answer is positive. So plus, this answer is 4. Minus minus plus, 5 2s are 10 and plus 2. Plus minus minus, 8 2s are 16. Plus, make this all the addition together. So 10 plus 4, 14. 14 plus 2, it's a 16. 16 minus 16, 0. So this one is also 0. So given all the three values in front of our polynomial, these all are the zeros of our polynomial. Now we will establish the relationship between the zeros and the coefficient. Okay. So now let's do it. Sum of the length alpha, that is equal to 1 by 2. Another 0 beta, that's a 1. And the third 0, that is gamma, that I am taking minus 2. These all are the 3 zeros. let 3 zeros. Okay. So now sum of the zeros, alpha plus beta plus gamma. So 1 by 2 plus 1 and the minus 2. Make the simplification. So what happened? It's a 1 by 2 plus 1 plus minus minus 2. Okay. And do the simplification. The 1 by 2 minus 2 and plus 1, it becomes the minus 1. So overall answer is it's a 2 ones are 2. So 1 minus 2 upon LCM is 2. So my answer is 1 by 2. Okay. And the sum of the zeros, that is the minus b by a. So if I check the value with the minus b by a, so minus, what the value of b? That we will get it after comparing this polynomial with the standard, that means general form of the cubic polynomial. So here the value of a, here I will write down value of a is what? 2. X cube coefficient, value of a is 2. Value of b, x square coefficient, that is 1. Value of c, x coefficient, that is minus 5. And value of d, that is a constant term. So now you can see here minus b by a. So b value is 1, a value is 2. So it's a minus 1 by 2. Both the answers are same. So alpha plus beta plus gamma, that is equal to minus 1 by 2, and that is equal to minus b by a. So first relation verified. Okay. Now we will verify the sum of the product of the two zeros taken at a time. So that we can write down like this: alpha into beta plus beta into gamma plus alpha into gamma. Okay. Now alpha into beta. What the alpha? 1 by 2. What the beta? It's a 1 plus. Again beta into gamma. Beta is 1. Gamma is the minus 2. Alpha is the 1 by 2. Gamma is the minus 2. 1 by 2 into 1, that's a 1 by 2. Plus minus minus, 2 ones are 2. And here 2 will be cancelled out, so only minus left and nothing is there, so 1. So it's a minus 1. So after that 1 by 2, minus 2 minus 1, it will be minus 3. Okay. And now take the LCM. What the LCM? 2. So 1 minus 3 2s are 6. So it's a minus 5 by 2. Okay. And let's do the sum of the product of the two zeros taken at a time, that is the c by a. And now here you can see this value is equal to what? C by a. What the value of c? Minus 5. What the value of a? 2. It's a minus c by, it's a minus 5 by 2, that equal to c by a. And at last the product of the zeros, that is alpha into beta into gamma. Alpha is what? 1 by 2. Beta is what? 1. Gamma is what? Minus 2. Okay. 2 will be cancelled out. What left? Nothing is there. So 1 and minus sign only one time. So in the product it's a minus 1. And that is equal to what? Minus d by a. Now check it. D by a. 2 by 2, that is 1. And minus d by a, so that is equal to minus d by a. Here I replace 2 and upon 2, so 2 will be cancelled out, so minus 1 will reflect. So this one is again the relation between the zeros and the coefficient. Okay. Now let's take the second example. Understood, Bicho? Okay. Now the second example also same way we can verify. For this second question, again we will check by replacing all these values one by one in our polynomial and verify they are zeros or not, and verify the relationship also. Now for this question number 2, our polynomial, suppose I say e of x is equal to x cube minus 4x square plus 5x minus 2. Suppose I will take the value 2 here. So it's a 2 the cube minus 4 2 the square plus 5 into what? 2n minus 2. Wherever x is there, each and every place that we have to replace here 2. Now 2 the cube is 8 minus 4. 2 the square, that is 4. 5 2s are 10 and minus 2. So 8, 4 4s are 16 plus 10. 10 minus 2 it becomes 8. 8 plus 8. 16 minus 16, that will be 0. So p of 2, that is equal to 0. That is 2 is a 0 of this polynomial. Now come to the second point. Right? Now we will replace here 1. So p of 1, that directly we will calculate. 1 the cube minus 4, 1 the square plus 5 into 1 and minus 2. Here x we replaced here. Okay, 1 the cube is 1 minus 1 the square is 1, so 4 as it is. 5 ones are 5 and minus 2. Okay, so 5 plus 1 6 and minus 4 minus 2, that is also minus 6. So overall answer 0. So p of 1, that is equal to 0. So 1 is also 0 of our polynomial. Okay, and 1 here given 2 times because they require the 3 zeros, that's why. So again no required about the third calculation. Okay, now let's verify the relationship between the zeros and the coefficient of our polynomial. So now for that, our polynomial we will compare with what? It's a standard, with the standard polynomial. So that is the value of a, coefficient of x cube 1, value of b, coefficient of x square, that's a minus 4, value of c, that is a coefficient of x, that is 5, and the constant term, that is equal to minus 2. Okay, now let's verify the relationship one by one. Sum of the zeros, alpha plus beta plus gamma. What is the alpha? So for that, first we will assume, let 3 zeros are alpha is equal to 2, beta is equal to 1 and the gamma is equal to 1. The 3 zeros already given, that we verified first they are zeros or not, and that we labeling it alpha, beta and gamma. Okay, now alpha plus beta plus gamma. Alpha is 2 plus 1 plus 1, so it's a 4. Okay, now alpha plus beta plus gamma is equal to what? Minus b by, let's check it, minus b by a. What the value of b? Minus 4 and upon a, that is 1. Okay, and minus is again ahead, minus minus plus, it's a 4 by 1. So you can see here. Okay, now first relation verified. Second relation, sum of the product of the two zeros is taken at a time, alpha into beta plus beta into gamma plus alpha into gamma. What the alpha? 2. What the beta? 1. What the again beta into gamma? What the beta? 1. What the gamma? 1. Now alpha into gamma. What the alpha? 1. It's a 2 and gamma is 1. So 2 ones are 2 plus 1 plus 2. That overall answer 5. Now alpha into beta plus beta into gamma plus alpha into gamma, that is equal to c by a. So let's check the value separately. C by a, otherwise you can make it here together. C by a. What the value of c here? What's the value of c is 5. Value of a here 1. So 5 upon 1. That is equal to what? 5. So they are all equal. Now the third relation, product of the zeros. Right? So it's a 2, 1 and 1. So the overall product is 2. And that is equal to, it should be equal to minus d by a. So let's check the value of the minus d by a. Minus, what the value of d here? Minus 2. Minus, then minus 2 upon value of a, that is the 1. And now you can check it, minus minus plus 2 by 1. So that answer is what? 2. Okay.